Okay, so let me get started with our lecture. So, any questions anyone has from the content that we covered in the previous lecture? I appreciate everyone asking question either at the end of the lecture last week, but you can also stop me in between and ask questions, right? So actually encourage everyone to ask questions, whatever things that you're not able to understand, because that is one way for me to find out that how much you have understood, and also for you to get any understanding which maybe you have missed or it's not clear to you, right? So today what we are going to do is we are going to cover a complete flow of client and server communication. Okay, so this is the flow that we go through every time when we use sockets for communication between the client and yes, sorry, screen is not shared in Unity. Okay. Okay, so we had looked at an example of get ADDR info, and basically what we said, what the get ADDR info does, it collects the hint, right? So it basically, first of all, it says that what type of socket that you want. You want IPv4 socket or IPv6 socket, right? Or you want the socket with TCP connection or UDP connection and so on, right? So you can filter the type of socket or the address that you want to connect to using the get ADDR info. And in the get ADDR info, we provide the IP slash service. So for that IP and service, it will find a particular socket with that condition or that filter. Okay, that is what we studied in the last lecture towards the end. So using that, I think these. So using the get ADDR info, what we do is that on the client side, right? So on the client side also we need the get ADDR info, and on the server side also we get ADDR info. So you have two applications that you are writing. One will be running as a client application. It could be running on a different computer, which is a client computer, right? And then you have the server component, which is running on the server side, right? So on both sides, we use get ADDR info. So on the client side, what we provide is the server IP or the host name to which you want to connect to, right? So you use the get ADDR info on the client component client side with the host name or the IP address of the server, so that we connect to that IP, right, with a specific service or a port number. On the server side, it uses the get ADDR info not to connect to the client, because that is not what the purpose is. But on the server side, it is using get ADDR info so that it can find the relative socket on the local server to which the connection request will be coming in, and it will be listening. Right. So on the server side, it is going to be listening to the socket on which the client connection is going to come. So in essence, you need to use the same filtering parameter on the client side, get ADDR info, as well as on the server side, so that we connect to the same type of socket. Let's say you connect to TCP on one side and UDP on another side, it's not going to work, right? So you have to use the same filtering parameter on both sides. Okay. So now let's assume that we have the socket information, right? We we have the socket information, but then using that protocol information, which is either UDP or TCP or IPv4 or IPv6. What we need is the file descriptor. So if you remember, I mentioned last week that any communication that we do, right, in the Unix-based environment, or any device that we use in the Unix-based environment, has to have file descriptor, right? Because all the communication, reading and writing, all of that is going to be done using only file descriptor. So what we do is that we use this socket system call. Okay, in the socket system call, we provide the information about the domain. The domain is the same as the family, which is either AF-INET or AF-INET 6, which basically tells you that it's IPv4 or IPv6 address, right? So we provide that domain information. We provide the type of the socket, which is either TCP or UDP. So stream or datagram, right? And then we provide the protocol, which is the default value generally passed as 0. So when you provide these three information, and this three information we have received using the get_addr info. So using the get_addr info, you already have this information that what type of socket we are trying to connect. So we provide that information to this socket system call. And what the socket system call is going to do, it is going to return you the integer value, and that integer value is nothing but the file descriptor. Okay, so basically it is mapping that type of socket to the file descriptor. So you have the mapping of file descriptor to that particular socket type, right? And we use, if you look at this diagram again, we use the socket call on both sides, on the client side as well as on the server side. On the client side, we are going to get the return value of integer, which is what we call client file descriptor or client FD. On the server side, we are going to call that value as listen file descriptor. Okay, so when the socket call is made from the client side, it is going to generate the client file descriptor, which then is going to be used to actually connect to the server for reading and writing the data. On the server side, we are going to create a listen file descriptor on which the server is going to listening for the client connection, right? So you need to have a server who is waiting for the client connection to come in or listen on. So that is what the server side listen FD is going to do. And you know, I'm going theoretical wise, but once we finish a couple of slides, I'm going to draw something which will make it more clearer to you, in case if it is not clear right now. These are the various domains that you can use, right? So you can use various type of network protocols. So AF-INET, we know it's IPv4, AF-INET 6 is IPv6. There are many other types of protocols. So Apple uses a special protocol called AppleTalk, right? If you use the wireless communication, you could use X25 or AX25. The Novell company, I don't know if anybody knows Novell Network. Novell Network was the first network company who designed the protocol for networks. And in those days, the networks were only local area network. There was no WAN then. This is, I'm talking about in the year 96, 97. No, sorry, 92, 93, around that time. Okay, because the company I work for, we had installed LAN in our premises, and we had bought the diskettes of Novell Network, and we actually installed LAN in our company for the first time. That was back in 92, 93. Okay. So that is the first time this Novell Network started giving us the software which will allow you to connect computers in your premises. Okay, so that is a special protocol again. They use IPX, which you can use. Unix has a special protocol called AF Unix, So only within the Unix network communication you can actually use that special protocol. So all of these different protocols are there which can be used for different purpose. Also the type of socket that you can have is again all of these, but generally speaking we use the stream, which is your connection oriented TCP protocol, and the dgram is the connectionless UDP protocol. So generally speaking we use the first two from here. Okay, so now you have the socket calls done on both sides. So on the client side, you have the client file descriptor. On the server side, you have the listen file descriptor. Now what happens is that on the server side, you need to say that the file descriptor that you got from the socket call needs to be bounded to the socket address, right? Because if you look at the get ADDR or the information that we provided to the socket system call, we have not actually specified any IP address port number information or the service here, right? So we're not actually saying that which IP and a port number on which the server is going to listen. Okay, we haven't said that yet. All we have done is that this is the type of socket, right? The type of socket is given to us, and we have just created the file descriptor using that type of socket information. But we have not actually used the socket address to map the file descriptor to that socket address, which is what this call is going to do, the bind. Okay? So we are binding, right? So we are binding the listen FD, which we got from the socket system call, to the server address. And this server address is basically your socket address, which is the combination of your IP and the port number. Okay, and what this, if you look at the type of data that we are passing here, structure socket address, and what that is what we studied here, ADDR info, right? Sorry, one second. SOC address. So SOC address is going to be your IPv4, IPv6 address, these addresses, right? Whether it is IPv4, IPv6, these structures are the ones that we are providing the pointer to. Okay, these are the socket address for IPv4 or IPv6. So depending on which IP you are binding, you will be providing the address of that particular socket in the bind call. Okay, here. And you will also provide the length of the socket address. Why we are providing the length? Because different protocol has the different size of structure. So IPv4 will have a different structure size, IPv6 will have a different structure size, and so on. So we are providing the length also along with the address. So this is the mapping that I have provided, right? So here you have the name of the domain or the type of the protocol that you are using, and then these are the structure that are defined in the kernel. So you can actually do the grep on your kernel source, and you will find that all of these structures are defined in the kernel source. Okay, and each of these structures are pertaining to a particular type of socket. Okay, so we have only looked at two, right? This one and this one. So these two are the ones which I showed earlier, right? So that slide is showing only the structure of these two, right? But there are many more which is equivalent to the other type of protocol that you can use. Okay, clear? Okay. Now you have what you have done so far. So you have the socket, type of socket that you got from the get ADDR info, and you have the socket address. Then in the socket call on the server side, you created the file descriptor. in the bind call, you bounded the file descriptor to the socket address. Okay. Are you following me too? Yes? Yeah? Okay. Now, the default socket is always going to be active. What it means is that default socket address is meant to initiate the connection. Okay, so it is assumed that the socket address, whenever you use, it is going to be initiating a new connection. But on the server side, we are not supposed to be initiating the connection. We are supposed to be listening on that connection, which means the socket is supposed to be in the passive mode, not in the active mode. So active mode sockets are the ones which are used on the client side, which is going to be initiating the connection. The passive sockets which are used on the server side, which is going to be listening for the connection. Okay. So the default socket type is going to be always active. So we need to use listen system call to change the type of the socket from active to passive. So we are basically telling that our listen FD, the file descriptor, which is mapped to the server socket, is now after the listen system call, it is going to be going to the passive mode for listening to the connections, right? It's going to be listening for the client connections. Okay. One more thing that you have to provide here is what we call backlog. See, for example, you have one network connection on a server. Now that one network connection, how many simultaneous client connection can be supported on that one Ethernet port? If I say unlimited, that could be a problem because your server application may not be able to handle, let's say, 1000 connections. It may be able to only handle 100 connections at a time, right? Depending on how much processing you are doing on your server application. So here in the backlog attribute, you provide the number of simultaneous connection that your server application can support. Okay, so your server is listening on a particular file descriptor, and you are saying that on this file descriptor, I can support maximum X number of connections, N number of connections. That is what this backlog number is going to be. If more connection request comes, it will be placed in a queue. It will not be serviced. So when the existing client who is already connected to the server, when they get disconnected, the new client servicing will start happening again. Okay. So this number is basically telling you at a time how many total number of client connections can be established by that file descriptor. That is another purpose of a listen system call. Finally, on the server side, we call accept system call. Accept system call is basically now going to wait for a client connection, right? So all these other calls that we have, get ADDR info, socket, bind, and listen, those 4 calls are made on the server side to have the server ready, right, to create the socket, to have the file descriptor, to have the file descriptor mapped to the socket, and to have the server ready for listening for the client connection, right? But then once we have the server ready, we call accept. So in the accept is the blocking call on the server side. So until the new client connection comes in, the accept call is not going to come out. Okay, accept call is not going to come out until a new client connection comes in. Okay, so accept call is the blocking call, and as you can see, we provide the listen FD as the file descriptor for accept. Right? What is this? What is this telling me? That on the listen file descriptor or listen FD on the server side, I'm going to be accepting the client connection, and when the client, whichever client is sending the connection request, once the connection request is accepted, that particular client's IP address or the socket address will be available to me. So on the server side, which client has sent the request, right? I need to know that, right? Because how will I be able to then send the data back to the client? I need to get the IP address of the client and ephemeral port of the client so that I can send the data back to the client, right? So that information is then available here. So when the client connection comes in on the server side, the accept call will come out, and the accept call will also provide you the client socket address, which will have the IP address of the client and the ephemeral port number of the client. Okay, so that is what happens on the server side. What happens on the client side? On the client side, we do the connect. So the connect call on the client side will let you map the client FD which was created using the socket system call, this one over here, right? So we did the socket call and then we call the connect. So in the connect, we provide the file descriptor on the client side that we created using the socket call, and then we say that map that to the server socket. Map that to the server socket. Okay. So this is the way the communication works. So let me actually show you pictorially, right? Because I think that will be better. We have 44 students online. Let me, I do have the pad. So let me try to connect with that and try to avoid there because that will be better. Okay. So what we are saying is we have a client and we have a server. Okay. Now there is a client FD over here. And then there is a listen FD over here. Okay. Now the client FD, okay, is going to be so my listen FD is connected. So let me put another bar here and say this is my SRV socket. Okay. This is my SRV socket, and then this is my client socket. Okay. So what happens is that my listen FD is connected to the server socket. My listen FD is connected to the server socket because my listen FD needs to listen on that server socket port and IP. Right, so that socket address that I have, which is on the server side, on which my server code needs to listen on, right? So my listen FD is connected to the server socket for listening. Okay, the client is going to be creating the will be connecting to the from the client FD to the server socket. So the client connection is initiated using the client FD to the server socket. Okay, so when the connection is sent from the client side to the server socket, on the same socket, the listen file descriptor on the server side is listening. It is a passive connection and it is listening. Okay, so now the server knows that someone has initiated the connection. Someone has initiated the connection. Okay, so once the server knows using the listen file descriptor that a client request has come in the accept call, the server will accept the connection. Okay, and when the server accepts the connection, if we look at the return value on the accept call, you will notice that there is an integer value that we are getting. This integer value is a new file descriptor which we call as connection FD. Okay, why that is? Because for listening part, server needs only one file descriptor because all the client requests are coming to the same socket. But then once the connection is established, you could have more than one client to be serviced using the same server. And for each of those connections, you need a new file descriptor. Okay, so whenever the accept call is successful, it creates a new file descriptor called connection FD on the server side. And that connection FD is on the server side, but it is mapped to, so let us say that connection FD is over here. Right, so this is, I'm going to call connection FD, right? So this one is connection FD, and this one is, if you see the accept call, in the accept call, we get the client socket address available to us, right? So this client socket address is now available to us after the accept call. What does it mean? It means that your connection FD is connected to the client socket address. Okay, so your client FD is connected to the server socket address from the client side. So you can use the client FD to send and receive the data to the server on the client side. On the server side, upon acceptance of the connection on the client side, the connection FD is created, and so this connection FD is then mapped to the socket address on the client side. So when the server wants to send or receive any messages to the client or from the client, then it uses the connection FD. Let's say there is one more client who is also requesting a connection. What will happen? Again, there will be a new client FD over here, right? So let's say client FD1, client FD2. Now this guy will again send the connection request to the socket server, right? So after servicing, after accepting the client connection request for this client, again the listen FD is free. Listen FD is free on the server side. Okay, so now the server is going to again listen to this new connection request. Once it creates the new connection request, it's going to accept the connection and it is going to create one more connection FD. So this is connection FD1, this is connection FD2. And so this connection FD is now going to be connected to the client socket address for the second client. So you have individual connection FD on the server side, which has a connection to the socket address of the client on the client side. This is how you can have multiple clients connecting to the same server. So there is only a single listen FD on which all the connection requests will be listened for, right? But once the connection request is accepted, then there is a new file descriptor that is mapped directly to that client socket address. And that is how the communication actually is going to happen. So basically, now here in this case, after establishing these two connections, server has two file descriptors separate, one for each client, right? So the again the communication between this client and this client can happen simultaneously, right? You can have the communication go together, right? Both the clients communication can happen simultaneously. This is how the socket works on the computers. Questions, doubts? Yes. Once the connection is established, data transfer will happen only through connection FD. Yes. So that is what I said. Connection FD is where reading and writing activity will happen. Listen FD is only to listen for new client connection. So that's why what happens is once the connection FD is established, listen FD is free for accepting the new client connection. That's why there are two separate file descriptors on the server side. Yes, दोनों साथ में. Right. So what will happen is that if two clients are requesting exactly at the same time, that is what you are saying, right? So listen FD accept call में है, accept is a blocking call. Two client requests came in, both will be placed in a queue in the kernel. So queue में कौन सा पहले जाता है? That will be service first. So the accept call will come out for that first client request, whichever is there in the queue, right? So again, what I'm trying to say is that on the listen FD, you can have the queue here, or you will have a queue here. So as soon as these connections are coming in, they will be going to the queue, right? So whichever is the first one will be serviced, and then once that connection FD is created, then the second one will be serviced. Sorry. Yeah, there will be a queue. Yes, there will be a queue, and that queue is like a buffer maintained in inside the kernel, right? Inside the kernel. Any other question? Okay. Yeah. So what I said is that, see, this connection request comes to the socket server socket, right? Which is where the listen FD is the file descriptor waiting for the connection request. Once it accepts the connection, then this connection FD will be created, and all the communication reading and writing from the server side will happen using the connection FD. At that point, this listen FD will be the file descriptor that will be freed to accept new client connections. That is what I was saying. Okay. Any other question? Yes. One. Listen FD you can have one. Uh, but if you want multiple connections on a single server, you can do that as long as you have a different socket address, right? What is a different socket address? Either you have different IP or you have different port numbers. So you could have a server running on 5 different port numbers, each one supporting 500 connections. You can do that, right? So basically, how many socket address you have, and that many number of listen FD you can support. Any other question? Yeah. In the queue, yes. Right. Correct. 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 So once the client closes the connection to the server, the connection FD is dropped or closed, and then you have, and that particular. So let's say if you are only supporting 500 clients, and there are already 500 clients, that one client is closing the connection, then you have 499 clients left, right? So you still have one more connection to be accepted, and that is how the new client will be new client connection will be accepted. Any other? Okay. So I mean, it's important for you to understand this concept, because this actually is the crux of everything, right? This is basically tell you that how the actual communication works in the network, right? That's why I'm taking uh, time to make you understand. I can show you the code immediately, but then it would be difficult for you to understand the code. So what I draw in the word, it's basically this, right? You have the client FD on the client side, you have the listen FD on the server side. Once the client request comes in, the listen FD is going to accept it, right? And then it's going to create a connection FD, and that connection FD is then going to be sort of connected with the client FD. Actually, it's not directly connection. Is the client FD connecting to the server socket and connection FD connecting to the client socket. That's how the connection is established. So I think this slide is just discussing the same point that we talked about. Uh, this slide also is going to be doing the same thing. So let's look at the code. Okay, so this is the client side code. In the client side code, we are accepting the argv1, argv2, which are the command line arguments, which is basically the server IP and the port number, okay, on which we want to establish the connection to, right? So we get the IP and the port number, or the host name and the port number, and then we call this function called open client FD. In the open client FD, first, we are just calling get ADDR info. Now here you will see that get ADDR info is connection to the server side, right? Because the host name and the port number is something that we are getting as a parameter to this function, which is the server host name and the port number. Okay. So we are getting the get ADDR info for the server IP and the port number. We call the socket to create the client FD, right? And when we call the socket, you can see that we are actually providing the information from the linked list that we got in the get ADDR info. So in the get ADDR info, we got the list P, which is the linked list, which has that particular type of socket address, right? And that is what we are going through in this for loop, and that is the connection that is the socket we are trying to get, right? If we are able to if you're not able to get the socket, then we continue, meaning try another node values. Otherwise, you go down, and then you're doing the connect on the client side. Okay, so on the client side, you are just doing the connect to the using the client FD and the server socket address, and that's about it, right? So this is the client side code for connection, for the connection part. On the server side, we are calling open listen FD. Here we just have one command line argument, and that command line argument is the port number on which the server is going to run. See, because the server is running on a local host, so we don't need to actually read the IP address. The IP address is the local host. Okay, so this is just the port number on which we are going to start the server. So in case if you want your server to run on multiple ports, you can run this same application multiple times using different port numbers. So for example, 15,000, 15,001, 2, 3, 4. Every instance of this application you can run using different port number, and whatever number of connections that you provide here, that many connections will be accepted on each of those ports. So when we do the open listen FD, again we call get ADDR info, but you can see that the IP that we provide here is null, because again this is for local host. So we don't have to provide the IP, we just have to provide the port number. We use the socket to get the listen FD. Then we use the listen FD to bind the listen FD to the socket address. Now this address is going to be server socket address. Right? So on the bind call, we are using listen FD to bind to the server socket address. And then we do listen. Right? In the listen, we provide the listen FD, and this is the number of connections that we will support. Simultaneous connection that we will support. 1024 for now. Right? Once these calls are successful, listen FD is returned from this function, and that is what we get here. And then finally, we call accept using the listen FD. And once the accept call comes out, we get the connection FD in return, and we also get the client socket address. Right? So this connection FD is mapped to this client socket address on the server side. Right? So that is how it is happening. And then we have the read and write communication. So for reading and writing, you will see that there is this echo function that we have created. And in the echo function, all we are doing is read using the connection FD, right? And also write on the same connection FD. So what we have actually written here is the echo service. Echo service is nothing but whatever data that you send to the server, the same data will be returned back to you in the echo form, right? So that's why it is called echo. So the client also is the echo client, and the server is also echo server. So all you are doing is sending the same data, receiving the same data back, right? Here also we are doing the same thing. We are reading some data from the keyboard on the client side, right? And then we are sending that data on the client FD, and then we are receiving the data on the client FD again, on the client side. So whatever you send, the same thing will be coming back on the client side. Questions about the code? Yeah. When you say server is full, meaning what? Huh? Yeah. Huh? Huh? Okay. So good question. So basically what will happen is your connect call will be blocked if the server is not accepting the client connection. Why? Because the connect call will only come out if the accept call on the server side comes out. Okay? Meaning that when the server accepts the client connection, then only on the client side the connect call will come out. So connect is a blocking on the client side, accept is a blocking on the server side. Okay? So we will have to wait till the connection actually happens, and that is only done once the connect call is successful. Okay. Okay. So let me show you how the code actually works. So what we have done is, since we have written two different code, right? One that is supposed to run on the client side, the other one supposed to run on the server side. we will be testing each one of them separately. Yes, generally speaking, whenever you write client and server code, ideally would be better if you can test it separately. Fortunately, there is a eco service that is already available to us, which runs on port number 7. Right? So port number 7 is where the default eco service which is running on the server on our computer. So we can use that default eco service to test our client, and then we will test our server using another tool called telnet. Okay, telnet is the tool which you can use to connect to a particular server which is accepting the data from the keyboard, which is like echo service. Okay, so that is what we are going to do. Why is making so much noise? Okay, so let us first test the client. And how do I know that the echo service is running? If I look at so echo service is running on port number 7 using TCP as well as UDP. So you can test the echo service using either the string type of socket or using the gram type of socket, both of them. Okay? But we are going to use the string type of socket. Yeah, I just use this one. Okay. Can you hear me? Yeah? No? Okay, but I don't know. Maybe the volume is low. Okay. So first I'm going to run the Echo client, right? And I know that the server is running on port number 7, right? And it's running on my machine. Now, if you want to test the server on a different machine, you can provide a different IP address. Okay, so I am going to provide localhost and the port number 7, right? Because the port number 7 is where the Echo server is currently running. Okay. So it is telling me that the host is this IP service 7. Why it is telling me that? Because if you look at this printf over here, right? I got the socket call successful, and I'm displaying whatever the socket address that I have from the get ADDR info, which is what I'm displaying over here. So it is displaying the host and the service in the numeric format because I have provided that I want to display the data in the numeric format. And now I am waiting here because the connect call is successful. If connect call would not have been successful, I would have not gone out of this loop over here, right? Now I can type whatever I want. And so the echo server is getting that data and it is replying with the same data back to me. And so my client is reading that replied data back and it is displaying that again, right? So the first one is what I typed and that was sent to the echo server. Echo server read that information from the connection FD and it sent the same data back to me using on my client FD, which my client FD then read, right? And that information is now displayed over here, right? So this is how you can test your client, right? But now I want to test my server, okay, without using client, let's say. So when you start this server, you only have to provide one command line argument, which is the port number on which we want to start the server, right? So that will be, let's say I give port number 15,000. So port number 15,000 is the port number on which my server is going to run. Okay, and it is going to be able to accept maximum 1,000 connections. So it is saying that my host is running on this particular port number and it is waiting for a new client connection. So if you look at that message is coming after this one here, right? So we executed all of the open listen FD function. In the open listen FD, we got the socket address, we got the listen FD from the socket, we bound the listen FD to the server socket address, and then we also called the listen. After the listen was called, then we are now in the accept. So this message is displayed and now we are waiting here. Okay, so accept is the blocking call on the server side, which is where now the server is waiting for a new client connection. What we will do is we will not initially use the client that we have created. We will use the telnet session. So I'm going to open a new terminal window. And I'm going to use the telnet port. Telnet. Now here I need to again provide the server IP and the port number on which the server is running. Right, because this is my client. So I'm going to say localhost and the port number is 15,000. Okay. So when I do that, you can see that telnet is telling me that connected to the local host. And on the server side, the accept call was accepted and therefore it is giving me the information about the client socket address. So this is my client socket address and this is my ephemeral port number. 35338 is the ephemeral port number assigned by the kernel to the telnet client. Okay, to the telnet client. So telnet client is running on localhost port number 35338. The server is running on 15,000 port on the local host. You can change the IP to go on the network, two different machines. You can do that. And now since the accept call is completed, it is telling me that start communicating with the client. And that message is coming from here. Okay. Now we are in this echo function. In the echo function, first we have this read call, which is again a blocking call, which is trying to read the data from the connection FD. So it is basically waiting for the client to send some data. Okay. So we are going to be sending some data from the client to the server, and that is what the server is going to echo back, right? So we read the data and then we send the same data back to the connection FD. That is what our Echo server is doing. So on the telnet side, where is my telnet? Here. Right. So from the telnet, I send the data, test message from telnet. This is the data I'm sending. Server is receiving that data. It's saying that I received 22 bytes, and this is the message I received on the connection FD. Right. And the same message is sent back to the client. That is what again the telnet is displaying. Right. So telnet is client on this side, which is sending the data and reading the data from my Echo server. So I tested my Echo client and I tested my Echo server. Right. So I'll close the telnet session. And when I close the telnet session, you can see on the server side, the client port has ended. The connection FD was closed on the server side because the client FD is closed. So once the client FD is closed, the connection FD is closed automatically on the server side. So now the server is again ready to receive a new client connection request. Okay. Now this time, I am going to use my Echo client and connect to port number 15,000, which is now for my Echo server, right? What happened? It will not provide the correct information. Sorry? Local host. Sorry. Server and IP, both. Right, so server IP, port number, and this is my connection from the Echo client. And so the ephemeral port is 35340. Okay. So this is how you can do the communication between the client and the server. And as soon as I close the connection on the client side, it will again close the connection on the server side and the new connection can be established. This is how you can set up the client server communication. Any questions? Yes. What is the telnet is the Echo client, but default Echo client given to us by the operating system. So if you don't have the Echo client program written by yourself, instead of using your own Echo client, you can use telnet. That is what I'm saying. So telnet is same as Echo client, and there is also Echo server or Echo service running on port number 7. We created our own Echo server, which we actually ran on port 15,000. Okay, so we are basically using the same two applications which are there in the kernel, but we wrote our own applications, right? Any other question? So when we write this server or when we wrote this server, there is still a problem with our server. Can anybody think about what could be the problem? Yeah. Right. So the problem is that if you look at the server that we have the communication in this main function. And main function is a single thread, single process, which is only assigned to a single core. So that means while I am in this echo function and while I am waiting for a read system call for that one client, I cannot have another client connection come in because my listen or my accept is not actually running at that point of time. So I have two blocking calls in my code. One is accept, one is read. If I'm in read, I cannot do accept. If I'm in accept, I cannot do read. That is the problem. Are you getting what I'm trying to say? Everyone? So what is the solution? Multi, huh? Why did I teach you multi-threading? What you do is that once the connection is established, once you come out of accept, the echo function is a threaded function. You create an echo function as a thread function. And you create a thread at that point of time as soon as you do accept, and then you call that accept, you call the echo function from the thread. So what happens is that every time there is a new client connection, each connection FD is passed to the new thread function or new thread, which is calling the same echo function. But so you have multiple threads servicing multiple clients at the same time, right? So that is the way we need to do the implementation. So by the way, that is one of the things that I think I've given you in the lab assignment. Right? You need to learn something new on top of what I'm giving you, right? So that will be the lab assignment. You know already how to do multi-threading. You know how to do networking. Now combine both of them together. Okay. Any questions? Okay. So I'll stop here. Uh, I'll let you grasp all the things we talked about today. Go through the material again. I mean, I've taught this course 4 times, 5 times probably, but every time when I talk about this, I get fascinated by the way the technology works. So uh, I sometimes get excited myself to teach you how things work. Okay. All right. So let's stop here. We'll. I think this Thursday is off, right? Thursday and Friday both are off, I believe. So I'll be talking to you guys on Monday. But try to take an advantage of this 4 day off for doing progress on your project, please. Right? Thank you.